So here we've got some state-of-the-art edging technology brought to us by those nice people at Brio. On the left you have the edger, and on the right you have the centering and blocking device that will prep the lens for edging. We begin by placing the frame in the tracing device. We've had patternless edges for the last 20 years. We can specify the type of frame, and then the tracing of the inner edge of the frame begins. You can see the tracing tool rotating around. We can now see the outline of each eye wire on the display. The cross running through the center, of course, represents the geometric center of each lens or each eye wire. We have the chance to override some of the measured values. So for example, we can adjust the distance between the lenses very easily. We place a lens into the tray below, and now we can enter for the right lens the monocular PD 29mm and then the cylinder axis 167. We do the same for the left lens, the monocular PD of 29.5 and the corresponding cylinder axis for the left lens. Now in the old days we would have to place a lens blank onto a lensometer and rotate it and mark the cylinder axis. But now with the modern technology it's all taken care of for us. So here we can see the outline of the frame superimposed upon the image of the lens. The lens has been rotated such that the cylinder axis is of the correct orientation. You can see the purple cross representing the geometric center of the eye wire, and the red cross representing the optical center of the lens. The yellow circle represents the target landing zone for the lens block. We'll see the lens block briefly and then watch it disappear. It's applied to the lens securely, and then the drawer will open and the lens can be extracted. We can see the lens with the block firmly affixed to the center, and we're ready for edging. So now we're looking at the edger, and the first step is to enter the job number, so the specifics of the frame are imported automatically from the centering and blocking device. We specify the lens material and the kind of bevel to be applied to the edge of the lens. Finally, based on our experience, we can make small adjustments to the cutting of the lens to ensure the optimal fit into our frame. We attach the lens. It can only go on to the edger in one particular way, and then we hit the start button. We confirm that we've got the right equipment in place, and the first thing that the edger does is to trace the edge of the lens, essentially checking the base curve of the lens so the appropriate bevel can be applied. Once that's done, the wheels start to turn, and the first step is to edge the lens down to its appropriate dimensions and size. Once the lens has been cut to the right size, a bevel is applied, so you can see as the lens rotates the bevel being applied, but at the moment it's something of a rough edge. So the final step will be to put a nice polish on that bevel. Water's applied at this stage, and you can see that the bevel is now nice and clear. So here's our finished lens ready to be placed into the patient's frame. So let's spend a couple of minutes seeing how the process differs for a bifocal lens. We select on the screen a flat top bifocal, and then we can enter the binocular near PD. The machine is going to base the location of the lens on the bifocal segments. Next we enter the bifocal segment height. In this case it's the same for both lenses. We can then place the bifocal lens onto the holder, making sure that it's sitting in there snugly and its orientation is approximately what we desire, but of course the machine will detect the orientation of the bifocal segment and rotate it accordingly. We still have the opportunity to make small adjustments to the rotation, so we can rotate the segment slightly clockwise or anti-clockwise, and we can also adjust the seg height manually. So here we can see the lens almost ready for blocking. The outline of the eye wire is superimposed on the lens. The purple cross represents the geometric center of the eye wire of the frame. The horizontal red line represents the top of the bifocal segment, and the vertical red line represents the midpoint of the top of the segment, and obviously if we extended that down it would pass through the optical center of the segment. We can place the magnetic adhesive block into the instrument, take off the paper cover, and that can now be applied securely to the lens. You see it disappear, and then the drawer will open and the lens can be removed. And you can see here the bifocal segment. You can also see a oblique line here representing the cylinder axis. But now we're ready for edging.